This is Mr. Tomlinson. Today we're going to talk about the quadratic family. Basically, we're going to be translating and transforming the graphs of quadratic equations or parabolas. Okay, so we're going to start by putting in some xy's in the table for the function f of x equals x squared. Okay, we're going to be looking at this function f of x equals x squared, and we're going to be plotting points. Okay, and we're going to start with the point 0, where we put in 0, and then we're going to put in a couple of positive points and a couple of negative points. So we're going to put in 0, and we're going to plug in 0, and for 0, if we plug in 0, remember that y is f of x, that's going to equal x squared. So 0 squared is 0. So we're going to put that in there, and we're going to plot this on the line 0, or on the graph 0, 0. Then see if you can plug in each of these points into y equals x squared, pause the video, and fill out the table here with the y values for y equals x squared, where x equals this. So you can see here I put the values for y in here into the table, and I've also plotted them on the graph. So I put 1, 2, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Now, if we ask the questions, what is the lowest point of the graph? If we look at this thing, then when we draw this smooth curve, what it looks like is a nice shape. It's actually kind of beautiful. It's got a perfect symmetry. And some of the things we notice is that it is symmetric. That is, perfectly reflects across the y-axis. And if I put in some more values, like 3, we would get 9. And negative 3, we would get 9. We could plug in those points, and then we could kind of continue this path of the curve going upward all the way to the end of the graph paper. So the lowest point of the graph is the point 0, 0. This point is called the vertex, and what we call the axis of symmetry. The axis of symmetry is the vertical line called x equals 0 or x equals a, whatever, but it is x equals the x coordinate of the vertex. The x coordinate of the vertex. So this is called the axis of symmetry. Okay, we usually label the axis of symmetry like so. And we draw a vertex like that. We'll label the vertex. So now we're going to ask the questions. We're going to use this graph to solve these questions. For what values does f of x equal 16? For what value of x? So that means basically f of what equals 16. So what value squared is 16? So it looks like to me this is 4 or negative 4. Because if I was going to go to negative 4, I would be way up here at 16. And if I was at 4, I would be way up here at 16. What value is 9? Well, that seems 3, because 3 squared or negative 3 squared is also 9. And same here, 5 or negative 5. And here, just one answer, which is 0. So for those of you who missed the class, I urge you to go on Desmos and plot these 3 graphs and see if you can make a general conclusion as to what is going on each time you put in these values, and see if you can make a general idea of what transformations are happening when you put them in the parentheses and when you don't, etc. Okay, so we're going to look down at this first graph, and we're going to go ahead and graph y equals x minus 1 squared. So the transformation of this graph is going to be to the right 1 unit. Now this may seem counterintuitive because it's going x minus, but because this is in the parentheses, the x has to be 1 larger than it was before in order to be where it was, for the y value to be where it was. So think about it. If I put in x equals 1, 1 minus 1 is 0, which is where 0, 0 is where the old y value was, so it's moved to the right 1 unit. Okay, so everything is going to move to the right, and what we're going to get is Then here and here. Should be up at 4. Apologies. Okay, and we're going to get this smooth curve like that, going through these 2 points. So basically everything shifted right 1 unit. So that's all. You took the parent function, what I call the parent function, y equals x squared is the parent function, okay? And we shifted it right 1 unit. We didn't change the shape of it. We didn't do anything. We just shifted it right 1 unit. Okay, the vertex is 1, 0, and the axis of symmetry is x equals 1. Change this to black. Okay, the next graph, x squared minus 4. If you plotted that on Desmos, you saw that this thing just basically shifted to the right. Or no, not to the right. It went down 4 units, down 4 units. And so what we ended up with is this graph right here. Draw a smooth curve. So this went down 4 units. And the vertex is 0, negative 4. And the axis of symmetry is x equals 0. So the vertex here is 0, negative 4. Axis of symmetry, x equals 0. All right, see if you can think about what happens when we do x minus 1 squared minus 4. Pause the video and try and plot that. So take a look here. When you have the y equals x minus 1 squared minus 4, you have shifted the curve to the right 1 and down 4. So right 1, down 4. Each time we do these, you notice that a negative transformation, y equals x minus 1 in parentheses and squared right here, this thing is going to be a horizontal shift to the right if it's minus and to the left if it's plus. And again, it's because this thing has been made smaller in order to be where it was in the parent function, y equals x squared. Y needs to be 1 larger than it was before, so it shifts to the right to be the same graph, shifted to the right. This value here on the outside of these parentheses just simply drops it down or up. If it's positive, it goes up. If it's negative, it goes down. That one's this type of transformation is fairly straightforward. Okay, so we're going to do some quick notes. I'm going to write these out really quickly and then I'm going to walk you through them. Okay, so if you're doing this at home, pause the video and take these notes down and then come back and I'll go over it. Okay, so what we have here is the quadratic parent function of y equals x squared. What you have is that you have the vertex at 0, 0. You have the axis of symmetry at x equals 0, which is the x coordinate in the vertex. The domain is all real numbers. The range is y is greater than 0. We can see this from the graph that all y values kind of stop here. They start here and they go up, I should say. If we draw any random line of y equals a that is positive, it will have 2 intersections here, and they will be equidistant from the axis of symmetry. Okay, if I go over here, I've translated y equals a times x minus h squared. Now this a we'll get into later, so just kind of ignore that. Assume that's 1 for now. H shifts the equation left, or shifts the parabola left or right, okay? And k shifts up or down. Remember, if it's x minus h, it will shift to the right. If it's x plus h, it will shift to the left. Plus k shifts up, plus minus k will shift down. The vertex will always be hk, and the axis of symmetry is x equals h, okay, which is the dead center of the parabola. Okay, so what you can try and do right now is describe the translations and try and check your understanding on the document here. And then after you've done that, whoops. So what you can do now is go ahead and try these check your understanding. And then the solution to this is posted on the planner and on the Canvas post I made on Monday. So yeah, that's it. Yeah, you can check these answers again on either Canvas or on the planner for today's date, which is Monday, or you can do it on Friday's date, both on the same date. But anyway, there you go. That's it.